guys, and welcome back to Aisha.Academy. And in today's video, we're going to be going through Sohcahtoa. So first of all, you're probably wondering, what does Sohcahtoa even mean? Is that even English? Well, it's basically used to remember the formulas of sine, cos, and tan. It is used for questions with right-angled triangles. That's a key point. If you've got right-angled triangles with another angle other than the right angle in the triangle. If you just have the right angle in the triangle and you're working out length, it's Pythagoras. If you've got another angle, you're thinking of Sohcahtoa, your sine, cos, and tan. So here is our right angle triangle, and we can see we have the other angle represented as theta, also known as the cucumber. So there are three key sides. One is the hypotenuse, which is the line that's always opposite the right angle. That's our H. We've got our O, which is the opposite, which is always opposite the other angles, the line opposite the other angle. And we've got our A, which is known as our adjacent. And our adjacent is the line that is always next to both angles, okay? So that's key. So first of all, the formula for SO, which is sine theta, remember sine and your angle, is equal to the opposite over the adjacent, okay? So opposite over the adjacent. And we use this formula to work out a missing length of either O or H. Then we've got our K, which is cos theta, okay? So it will be cos theta is equal to our A over H. And then we've got our TOA. So our TOA is tan theta is equal to the opposite O over the adjacent. And these three formulas, we use them if we want to work out the missing length, all right? So if there's a missing length, we use these three formulas. Whereas you've got these other formulas, so for SO, it would be the angle is equal to sine, inverse sine, right? That's the key point. And inverse sine in your calculator is sine minus 1, okay? And that would be sine to the power of minus 1 in your brackets would be O over H. And to get sine minus 1, you press shift first, then press sine. So shift, then sine. To get inverse cos, where you can see where this common pattern is occurring. So the angle that you're trying to work out if it's cos, okay? So cos to the minus 1, again, you would press on your calculator, shift, and then cos to get that coming up. So it will be cos to the power of minus 1 in your brackets, A over H. And then for TOA, when you're working out the missing angle, it's going to be theta, the angle, is equal to inverse tan. Again, same thing. You press shift, then tan, and it will come up with tan minus 1 in your calculator. Okay, and then in the brackets, it's going to be O over A. So the key thing with these other three formulas, right, is that we would use them if we're working out the missing angle. All right, so this is a key point. Okay, we're going to head on into some practice questions to consolidate our learning. So, example number 1. So, in this question, we've got right angle triangle, and another angle, and it wants us to work out what the other angle is. So, the first step in answering a Sohcahtoa question is you want to label the triangle. So, that's our O, the line opposite the angle, our H, opposite the right angle, and our A, next to both angles. Now that we've labeled, we're going to work out which part of Sohcahtoa we're going to use. So in this question, they've given us the hypotenuse, H, and they've given us the adjacent, A. So the only one with an A and H in it is K, so we're going to be using cos. Then we're going to use the formula for K angle equation to work out the angle. So it's going to be x, the angle, is equal to cos to the power of minus 1. Remember, inverse cos. And in our brackets, remember, it was A over H. So it's going to be the A, the adjacent, divided by H in your brackets. We're now going to substitute those values in. And when we substitute that in, we're just going to replace the A with the value they've given us, which is 6.4. So it's going to be 6.4 divided by the replacement of H, which is 9.6 for this question. And when you put that into your calculator, you would come out with an answer. So this is just reminding you to press shift then cos to get cos minus 1. So putting that all in would leave you with 48.2 degrees to 1 decimal place. Example 2. So here again, right angle triangle. We've got a right angle and another angle, but this time we're working out the length. So same step as before. The first thing you want to do is label your triangle. So we've got our H, we've got our O opposite the other angle, we've got our A, our adjacent next to both angles. Now we're going to work out which part of Sohcahtoa we're going to use. So in this question, they've given us the hypotenuse, which is H, is 32 centimeters, and we're to work out O. So because we're using both O and H, we're going to be using SO. So we're working out with sine. And then we're going to use the equation for SO when we're working out the length, which was sine and then the angle, which is 60 degrees in this case, which we'll substitute in later on. But the formula was sine theta is equal to O over H. So now we're going to substitute all those values in, which is sine 60 degrees is equal to O we don't know, so we're going to put that in as x, as they've given, and that's going to be over 32 centimeters. So now we're going to have to rearrange this formula to make x the subject, which ends up as sine 60 times 32, which would leave you with 27.7 centimeters. Okay, so the key thing here is that sometimes you may have to rearrange the formula using your general algebra knowledge. All right, but I hope that was useful in terms of Sohcahtoa, and thanks for watching, guys, and stay tuned for more content.